Hey guys, so today's lesson is the law of sines. We have a few objectives. First, we're going to focus on solving side angle angle and angle side angle triangles. When I say solve a triangle, I mean find all of the missing sides and all of the missing angles. After we meet that objective, we're going to work on solving side-side angle triangles. I know a lot of people probably notice that could also be angle side-side triangles, and I really don't mind if you have to remember it that way, because side-side angle triangles create very interesting circumstances and puts us in a very interesting situation. If it having a funny name makes it a little bit easier for you to remember that that's a special case, then let's do it. After the first two objectives are met, we're going to work on applying the law of sines to solving word problems. So let's get started. First, let's define what it is to be an oblique triangle. If a triangle is not a right triangle, then it is an oblique triangle. Basically, an oblique triangle is any triangle that doesn't have a 90-degree angle. What can we say about the angles in an oblique triangle? What can we say about the angles in a right triangle? If you have a right triangle, one of the angles is 90 degrees. The other two angles must be what kind of angles? When we have a right triangle and the other two angles, alpha and beta, are unknown, we could at least say that we know alpha and beta are complementary angles. They have to add to 90 degrees because the sum of all three angles inside of a triangle is 180 degrees, 90 of which are taken up by the right angle. If you have two angles that add to 90 degrees, that means alpha and beta must both be acute angles. There are two possible scenarios when working with oblique triangles. In the first scenario, the triangle will have three acute angles. In the second scenario, there will be two acute angles and one obtuse angle. So as you can see, an oblique triangle will have either two acute angles and one obtuse angle, or three acute angles. An obtuse angle is an angle with measures between 90 and 180 degrees. Keep that in mind. Before we move forward, I'd like to go over how we should be labeling our triangles. When you draw a triangle, whether it's to scale or not, I want you to use capital letters for all of your vertices, and then we will refer to each of the angles by that capital letter. I tend to default to A, B, and C. Each side should be labeled based on the angle it's across from. BC has normally been an acceptable way to name a side of a triangle. However, instead, I would like you to label side BC as lowercase a. Side AC, I would like you to label lowercase b. And AB, I would like you to label lowercase c. We're going to follow this method for the next few sections. To solve a triangle means to find all side lengths and all angle measures. So here we've drawn another triangle using A, B, and C for both the angles and the sides, capital letters for my angles or vertices, and lowercase letters for the sides opposite each of those angles. If I were to successfully solve this triangle, I would be able to tell you what the angle measures of A, B, and C are, and I would be able to tell you what the side lengths of A, B, and C are as well. So what is the law of sines? And how is it going to help us? Let's find out. The law of sines. For a triangle with sides A, B, and C, lowercase letters, and opposite angles A, B, and C, capital letters, respectively. Respectively just means in that order. So A and A are opposite each other, B and B, C and C. Our order is intentional. Then the law of sines is sine of A over A equals sine of B over B, which also equals sine of C over C. Couple things before I continue. If I'm saying sine of A, even if you couldn't see what I have written right now, you should know that the A I'm taking the sine of represents an angle measure. You do not take the sine, cosine, tangent of a side length. We take trig ratios of angles. Sine of angle A, okay? That won't be a side ever. Next thing, second thing before I continue. I know that this has two equal signs and three pieces to it. You don't set up all three parts and try to solve from here. You choose two parts and set them equal to each other. They're all equal. If you happen to know angle A and side A, and you know angle B, well then we're going to use that and find side B. If you know C and C, and you also know side A, well then I'm going to use those and solve for angle A. You won't set all three up at the same time. That's silly, okay? So those were the two things. Now, or we could look at this exact situation as the reciprocals instead. This is totally fine. Some people prefer this when they're solving for a missing side because by it being in the numerator, you're less likely to mess up isolating your variable. And some people like this better when they're solving for an angle. But these are the exact same things. So side A over, well, I should watch how I say that because side, S-I-D-E, side A over sine A, as in the angle, okay? Equals B over sine B equals C over sine C. So let's write down when each is ideal. Most people will use this every time and call it a day. They're fine with it, okay? But if you want to pick and choose for which is best, I would say this one is best when you're solving for an angle, and this one is best when you're solving for a side. But like I said, most people are really just going to default to one and use that same one every single time. There's nothing wrong with that. I'm just giving you some advice. Example 1. Use the law of sines to solve the following side, angle, angle, triangle. We're given A is 40 degrees, B is 60 degrees, and A is 4. Even if I didn't tell you if it was capital or lowercase, by using the units of degrees on the first two, you should know that those are angles. Now, what strategy should we use? Well, one thing I like to do is I like to draw a picture. Then I like to write out ABC capital, ABC lowercase, whatever way you want to do your columns, and I like to have them side by side because we will be able to tell if our answers make sense as well. So when you draw a picture, you really don't need to keep it to scale. You could do your best to try. Anytime you have two angles, you really have all three. Since we're given that angle A is 40 degrees and angle B is 60 degrees, the sum of those two is 100 degrees. Then we know angle C must be 80 degrees. We really don't have to use the law of sines to figure out that missing angle because we know the sum of all three angles equals 180, and we're already given 2 of the 3 angles. When given 2 angle measures, find the third angle first. We're going to use A plus B plus C equals 180 in order to do that. So we aren't using the law of sines just yet. I have 2 side lengths that I still need to find. None of these angles are right angles, so this is definitely oblique. I can't use Pythagorean theorem, and I also can't use right triangle trigonometry. Right triangle trigonometry is when we use SOHCAHTOA, sine being opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's only allowed to be used on right triangles. Since we don't have a right angle, we're going to have to use another method. Now I'm going to draw a picture of an oblique triangle, and I'm going to label my angles as best as I can to being in the right order, where A is going to be on my most acute angle and C will be on my biggest angle. It looks like this is my biggest angle, so I'll call this C. And this looks like my smallest angle, so I'll call that A. Therefore, this is B. Another thing that we should remember is that the smallest angle will be across from the smallest side. The biggest angle will be across from the biggest side. Therefore, side B will be my median side length. Here I have A equals 4. Adding the numerical values to the picture isn't totally critical, but it does help tie things together so when we're doing word problems later, we'll have a better understanding. Also, the side-side angle is a very unusual case, as I mentioned before, and having a good understanding of the visual will really help you out. Okay, law of sines. In order to do law of sines, the second phase, we need to identify which angle-side pair has a complete set already figured out. That would be A. When I set up my law of sines, I'm going to use sine A over A as one of my ratios. We're going to use that ratio. For the other ratio, we could really use any pair we want. First, I wrote the rule. Now I'm going to fill in all of the values I know. If I have 4 variables in my equation and I'm trying to use it to solve, that means I should be filling in 3 out of the 4 variables. I'm going to multiply both sides by b. If you just divide by sine of 60, b will be in the denominator and that doesn't help us solve. Now I'm also going to multiply both sides by 4. And I'm going to divide both sides by sine of 40. That leaves us with b equals 4 sine 60 over sine 40. And that was an awful lot of work for something that could have been a lot simpler. What do I mean by that? Well, on the previous page, I had told you that we could have set up our ratio the other way around. By setting up our ratio the other way around, it would be easier to solve for a missing side. Let's see how that would work. Here I have it set up with the reciprocals of this equation. 4 over sine 40 equals b over sine 60. To get lowercase b alone, all we need to do is multiply both sides by sine 60. Now, I didn't show the work just because I ran out of room, but I hope you can see that we get the exact same expression set up for the value of b in both ways, but this one's a lot cleaner. Now that I have b set up like this, whatever way you decide to do it, all you need to do is evaluate this in the calculator. You always want to make sure that your calculator is in the right mode. My calculator is in degrees, so it's going to understand that 60 and 40 represent degrees and not radians. This is good. Now, in this calculator, I can type fairly straightforward. So, 4 times the sine of 60 divided by the sine of 40. 5.389 is the side length for side B. Now I'm going to find side C. As a piece of advice, I think it would be a good idea when finding side C to go back and using the whole numbers that we were given at the beginning of the problem, and not to use this pair of angle B and side B because this side length is clearly rounded. I'm going to set this one up the way I did this one right over here. 4 over sine 40 equals C over sine 80. If I multiply both sides by sine of 80, and careful, don't mess up while you write things down, I'll have the trigonometric expression of 4 sine 80 over sine 40 as being equivalent to side C. Now, I'm going to type that into the calculator to find the approximate value. 6.128 is the approximate side length for side C. So here was an example of us using the law of sines to solve a triangle. The triangle was a side angle triangle. We were given side length A is 4 and angles A and B were 40 and 60 respectively. This meant we needed to solve for angle C and sides B and C. My advice to you is to first, when given 2 angle measures, find the third angle. So that's a definite first step to help yourself get this done quickly and efficiently. You have 2 of the angles in a triangle, find the third angle for sure. Next, determine which pair of letters you have completed. Do you have both A's, both B's, or both C's? In this case, we had A and A. Now, you might not have A and A obvious to you immediately. You might have to do this step here first in order to have your full pair. That's why it's really important we do this first. Make sure you write that down, and make sure you write this down. After we decided which full pair we had, we set up our law of sines and we used the ratio involving that angle side pair. From there, we just use basic algebra to solve for the remaining variable. Let's try a different example. I'm going to set up this problem the same way I set up the other example. I begin by writing out the capital letters to represent my angles beside the lowercase letters to represent the opposite sides. I'm going to fill in the values that I already have, and since I have 2 angles already, I will find my third angle first. The C value looks very similar capital and lowercase, and if your handwriting's messy, it could get a little confusing. But if you're very good about remembering to use the degree symbol whenever you write an angle, you probably won't mess up when you're given a side or an angle C value. 35 plus 15 is 50. If there are 180 degrees inside of a triangle, how many degrees are left for angle C? Angle C has to be 130 degrees. That's my biggest angle. So I definitely took care of my first step, where I was given 2 of the 3 angles and I found the third angle. Next step, identify which pair of capital and lowercase letters we have figured out already. Well, big C and little c, got it. Next, we're going to use that ratio. Now, while we don't need to draw this out, it can't hurt. This time, I'm not going to label my picture the same way I did in the last problem. By that, I mean I'm not going to put my side lengths or angle measures in the picture. I'm really just going to have this here for reference in case there's any issues. Since I'm finding a side, let's set this one up correctly from the beginning. I know I need to use my pair of C's as one of my ratios, and the other ratio could be any pair of letters, so I'll just use A. Now I'm going to fill in everything that I know. To get the lowercase a alone, I'm going to multiply both sides by the sine of 35 degrees. Because I set my problem up this way, getting lowercase a alone was actually pretty easy. Now, my exact answer is 5 sine 35 degrees over sine of 130 degrees. That's the exact value because I didn't have to round. The approximate value will be what I write over here because I'm going to have to round. 5 sine 35 divided by sine 130. 3.744. In the last example, I put stars next to all of the values I found myself, so I remember that those weren't original values provided by the question. Now I'm going to circle back around and use C over sine C equals B over sine B. Similar to the previous example, I'm going to get lowercase b alone by multiplying both sides by the sine of 15 degrees. Here I have the exact solution, 5 sine 15 over sine 130. I'm going to find the approximate solution with the calculator. B is approximately 1.689 units long. Another reason it's good to list each pair of side and angles that are opposite each other side by side is it's easy to check if your answers make sense. 130 degrees is my biggest angle. It should be across from my biggest side. 15 degrees is my smallest angle, and it should be across from my smallest side. This checks out, so at least I know my answer makes sense. Let's look back at example 1. In example 1, 80 was my biggest angle, and it was across from 6.128, which was my biggest side. 40 was my smallest angle, and it was across from 4, which was my smallest side. These answers also check out. That's the end of our first objective. We've just solved two triangles using law of sines, the first of which was a side angle angle triangle, and the second was an angle side angle triangle.